morning, this is Dr. Turner for Integrated Math 3. Today we're going to be covering the last section in Unit 4, which is 4.4, Solving Rational Equations. Solving these rational equations is going to involve looking at everything we've done so far in both Unit 4 and 3, so keep that in mind. But once you get the hang of it, hopefully it won't be too bad. Let's go ahead and get started. So to start out, I'll give you a couple easier examples. It might be something like, adjust that size there, might be something like, oh, there we go, 1 over x equals 4. Right? So technically, that's involving a rational expression because we have 1 over x there. Here, when you are looking at fractions and whole numbers, typically what you're going to want to do is put a 1 under any whole number. Then this is a cross multiplication problem where I can do 1 times 1 and x times 4 to get 4x equals 1. And if I divide the 4 on both sides, I get x equals 1/4 or 0.25. So some of these problems will be as simple as that, of just basically doing cross multiplication, which is something we've done before. 1 over x equals 2/3. Same thing here, cross multiply, 1 times 3 and 2 times x, and then divide by 2. These could be a little more complicated, but the same process, 1 over, say, x squared minus 4 over 7 equals 2 over 7, for instance. So here, this goes back to looking at 4.1 through 4.3. In these examples here, I don't have the same denominator. And so I want to do a couple of things. One, I want to rewrite this in a way that I only have a single expression or a single fraction on both sides. And to do that, I'm going to need to look at like terms. So here's one way we could approach this. It would be to first, look here on the left, I have 1 over x squared and minus 4 over 7. So to look at the least common multiple here, I would need to multiply the left fraction by 7 and multiply the right fraction by x squared. And don't forget our 2 over 7 on the end there. So that would give me 7 minus 4x squared. In the denominator, I would have 7x squared as a single fraction. So one way to solve this would be to leave it as so and cross multiply. Okay? So up to you from this point what you want to do. There's another technique we'll talk about here in just a second. But let's say I decide, okay, I have a single fraction on each side, cross multiply. Being careful with your distribution, if you have something other than a monomial, you have 7 times 7 minus 4x squared, and that's equal to 2 times 7x squared. We end up with 49 minus 28x squared equal to 14x squared. From here, I want to group all of my variable terms on one side. And then, because I don't have a b term, because I only have an x squared and a constant, I'm going to leave the constant on the other side. So, I would add 28x squared on both sides. I would divide both sides by 42. This fraction is able to be simplified because they're both multiples of 9. So that would be 7 over 6. And then I would take the square root, keep it in mind plus or minus. Now I can't leave it like this, so it's going to depend on the specific topic of what you're asked to do. Here, I want you guys to simplify the radical. So you can separate the radical sign top and bottom. And remember that we can't leave a radical in the denominator. So I would multiply top and bottom by radical 6. which would give me the square root of 42 over positive 6, plus or minus. And that would be considered your simplified answer. And number 3 there got a little messy. For your assignment, the 10 questions, you're not going to have any that are that complex. You should be able to simplify it first and hopefully get integer solutions or at the very least a simpler rational expression. But remember that not every answer is going to be an integer. So just be aware of that. Let's try that again. Let's say 4 over x plus 1 minus 3 over 5 equals 2 over x plus 1. So I want to write the first fraction, the first side as a single fraction. So I would need to multiply the right side by 5. And multiply the right side by x plus 1. So we end up with 20 minus, distribute, 3x minus 3 over 5 times x plus 1. Now, we could cross multiply from here if we want, after we, of course, clean up that numerator on the left by combining like terms. However, I might also recognize that looking at the left and right-hand side, these are almost the same in terms of the denominator. And we talked about this in 4.3, where if I have the same denominator, I can eliminate it by multiplying both sides by that same expression. So you could still do the way we did number 3, or if I multiply the right fraction by 5 top and bottom, that would give me negative 3x plus 17 over 5 times x plus 1 equals 10 over 5 times x plus 1. And so if the denominators are the same, when we cross multiply, we're going to end up with the same term on both sides. So we can either multiply or divide that out. And now I'm just looking at the numerators. Negative 3x plus 17 equals 10. Subtract the 17 on both sides, and then divide by negative 3. Pay attention to what it's asking you to do here also. As a general rule of thumb, you are going to have as many solutions possible as the highest degree once you've done your cross multiplication. So in the example number 3, we ended up with an x squared, and therefore had 2 answers. And number 4, we ended up with a linear term, therefore we had 1. So keep that in mind. Continuing on that point, like we saw in number 4, where I'm sort of rearranging it so that I have the same denominator, you could take that a step further, like we did in 4.3, where we're looking at possibly factoring, depending on the given problem. So let's look at something like number 5 here, where I have x squared minus 49 over x squared minus 10x plus 21, and that is equal to 6 over x minus 7 plus 6 over x minus 3. So here we already have a single fraction on the left side of the equal sign, but not on the right. So we may want to first write the right-hand side by multiplying the right term by x minus 7 on top and bottom, and multiplying by x minus 3 on the left top and bottom. So that would give me 6 times x minus 3 plus 6 times x minus 7, and that's all over x minus 7 times x minus 3. Now, sometimes we're going to end up with like a situation like this where, again, you could multiply just as is if you want, but if you do that, you're going to have x squared times x. You're going to end up with a fourth degree polynomial. So typically, if it looks like this, there's something that we can do to either simplify or combine like terms. So what we've been doing in class is saying to factor, if possible, and then see if there's anything that you can cancel out. Okay. So using your factoring techniques, the top would factor it into x plus 7 times x minus 7. On the denominator, it's x minus 3 times x minus 7. You're going to combine like terms here to get 12x minus 60, and that's over x minus 7 times x minus 3. So from here, again, multiple ways we could do this. I could start out by simplifying one of the sides before I'd choose to multiply. But also, as we just saw in number 4, if the denominators are the same, remember commutative property, this is the same thing. If the denominators are the same, then I can just set the numerators equal to each other, because those would cancel out on both sides. Okay. Now from here, we still end up with a quadratic. That's okay. It might be factorable, it might not be. So I'm going to put this back in standard form. And I'm going, because I do have a b term here, I'm going to write everything on the same side. So I'm going to subtract 12x, and I'm going to add 60 to both sides. From here, you can use any of the techniques that you've learned about quadratics. If you can factor, that's usually the easiest way. So the numbers that multiply to get 11, but add up to negative 12, are x minus 1 times x minus 11, which means my two solutions are x equals 1 and x equals 11. So, for this lesson, you are simplifying when possible. You are using your rules from 4.1 through 4.3 in terms of adding, subtracting, multiplying, dividing, simplifying. Once you do that, and once you simplify, you're going to end up with, if you've done so correctly, you're going to end up with either a linear function or a quadratic function. If you end up with a higher degree polynomial, that doesn't mean you did it wrong. You may have been able to simplify somewhere along the way. So I would double check that you simplified it. And if that's not the case, then you can use synthetic or long division to try to find your solutions. For this example, I didn't give you any that should be the case. So you're looking at mostly examples 1 through 4 with a few example 5s sprinkled in. If you guys have questions, please reach out to me, attend office hours if you need to. Otherwise, have a good day, and I will talk to you soon.